At the beginning of our discussion on this chapter, we did emphasize that we're going to be talking about where data comes from. And so at this point, we want to answer that question. All statistics starts with data, but then where does this raw material for statistical analysis come from? The first source is from experiments. You see, many of the drugs that we take come with a prescribed dosage. How do they get that dosage? It comes from an experimental process. So, statistically speaking, what is an experiment? An experiment is a process that produces a single outcome whose results cannot be predicted in advance with certainty. So, let's take, for example, the Georgia company, which is a pharmaceutical company. It recently conducted a study in which 20 people were given a new drug and 20 other people were given a pretend drug called a placebo. Now, what is the objective? They would like to see if there's a difference in pain relief between those who are using the new treatment or the new drug versus those who are using the placebo. Of course, the best method of collecting data to answer this question of whether there's a difference between the two groups is using an experiment, possibly in a laboratory. The explanatory variable, or the variable that we want to see how it reacts, is the drug type here, and the response variable is the level of pain relief. So the response variable will be the variable that responds to changes in the drug type. And so we are hoping that the differences in drug type will explain the differences in the level of pain relief. In order to carry out an experiment, you must have a plan for performing the experiment. That plan is called an experimental design. It is a plan in which the variable of interest is defined. You have to define your explanatory variable, and you have to define your response variable. And of course, it must be reasonable that there's a connection between the response variable and the explanatory variable. So, the key point we want to highlight here is that the first source of data collection is from experiments. Another source of data is from telephone and internet surveys. Have you completed a survey presented to you online before? So, one of the key characteristic advantages of surveys and surveys, whether telephone or internet, is that they are inexpensive and efficient, and sometimes it does come with its own disadvantages. We have response rates that can be reasonably low, so low that the information collected from that sample data might not truly represent the entire population. And so that is usually an issue to contend with. Online surveys are being used more frequently these days. Sometimes there are incentives that are given in order to help to boost the response rates. Technology has helped to eliminate postage costs and has made it easier to also format the data for statistical analysis. Then, beyond surveys, very similar to them are written questionnaires. So, if you go to the hospital, for example, and you have to complete or update your medical records, they might give you a couple of forms which you have to complete by writing on the paper. These are examples of written questionnaires, and they are also very frequently used. Um, Sometimes you can also have mail questionnaires that would require postage to and from the respondents. So far, we've talked about experiments, we've talked about telephone and internet surveys, we've talked about written questionnaires. These are all examples of sources of data or instances from which we can collect data for analysis. There are more. Let's see on page 16. We talk about observations and interviews. So let's say you're an individual works in a place, in a plant, and there's a safety inspector who's on ground to observe you at work. By observing what you're doing and making a record of what is being observed, what is recorded as observations constitutes data, and so observations can stand as an example of a source of data. So also are interviews. Interviews can come in the form of personal interviews, which can either be structured or unstructured. What is the difference between structured and unstructured interviews? For structured interviews, the questions are scripted. Otherwise, for unstructured interviews, this is more of go with the flow. Interviews begin with one or more broadly stated questions, and other questions build off of the previous questions or responses. Then, what kind of questions are mostly fielded when you're conducting an interview? You have open-end questions, closed-end questions, and demographic questions. With open-ended questions, the respondent is free to choose how they want to respond with any value, words, or statements, whereas with closed-end questions, the respondent has to select from a short list of defined choices. Then for demographic questions, it has to do with questions asking for the respondent's characteristics, backgrounds, or attributes. Let's take some example questions. In the first question, which of the following types of questions provide the respondent with the greatest choice in responding to a question? This would be open-end questions. Next question. One of the major challenges for developing a good written questionnaire or telephone survey instrument is that your wording, the way you word the question, can affect the truthfulness or the veracity or the quality of response provided by the respondent. Last question here is, if a pet store wishes to determine the level of customer satisfaction with its services, do you think it would be appropriate to conduct an experiment? I would argue no. You don't want to toy with the quality of the services you offer to your customers just because you want to assess how they will react. That would not be particularly ethical. So, because it may be unethical to subject different customers to different levels of treatment, just in order to gauge varying levels of what customer satisfaction, an experiment would not be appropriate. Now that we understand the different sources from which, or the different methods um, from which data can be collected, or that can be used to collect data, rather, we are now ready to look at sampling techniques. Remember that in an earlier video, we talked about how when we want to study a population, we can take a sample out of that population. But what we have not discussed are the methods of taking a sample from that population in such a way that the sample we have taken is truly representative of the characteristics of that population. So, to begin with, the process or the methods or the techniques that are used in statistics to select a portion or fraction or subset of the larger population, that process is called sampling. So here's an individual thinking about how do we get a sample. We can use two major techniques. We can use statistical or random sampling techniques, or we can use non-random or non-statistical sampling techniques. For now, we're going to focus on the most encouraged form of sampling techniques, and that is statistical or random sampling techniques. So we talk about the first one, namely simple random sampling. In my opinion, I think that the simple random sampling method is one of the ways you pick a sample from a group in such a way that everyone has an equal but non-zero chance of being selected. Take for examples, if you have a group of 25 students and you have all of them write their names in this hat and write their names in a piece of paper rather, and then throw it all in this hat. and you shake the hat so well and have a random person dip their hand into this hat to pick the names of 3 students to represent the class in a particular convention, what do you think? I think nobody will complain because they would agree that each member of the population from which the sample to be selected had a chance of being selected. And so this will constitute an example of a simple random sample. So how can a simple random sample be selected? You can draw a name out of a hat, you can use a random digit table, or you can use a random generator. These are all examples of how a simple random sample can be selected from the entire population. Now, another type of statistical random sampling technique is stratified random sampling. Now, rather than reading a story to you, I'm going to use an illustration. I'm using this picture. Here is the goal. In total, there are 42 in the entire population. Our goal is to be able to pick a sample of size lowercase n equals 12. So this is where we're starting from, and this is our goal, to pick a sample of size 12. Well, what we observe in the population is that we have an heterogeneous group. What I mean by that is the units in the group are inherently different from one another. You have the green, the red, and you have the purple. So what we're going to do, if we're going to use stratified random sampling, is that we're going to define a stratification variable or a method or a basis for which we'll separate the heterogeneous groups. So we're going to use color in this case. So we have green, and we have red, and we have purple. So how many in total? We're going to count each of these numbers, 14, 21, and 7. And the total is 42. So what percentage of green do we have in the entire population? To calculate that, we'll say 14 divided by 42 times 100%, that gives approximately 33%. Then 21 divided by 42 times 100%, that gives 50%. And 7 divided by 42 times 100%, that gives 17%. So this percentage composition will be used to choose the 12, the 12 that will be in the final sample. What I mean is we're going to separate all the green faces, the red faces, and the purple faces. And then out of this number, this 14, we're going to say that 33% of the 12 that we finally need should come from the green. So this number, 33% of 12, that will be 4. So 4 random green ones will be selected. Then this 50% will be 50% of all 12 sample, of 12 in the sample, would come from the red group. So 50% of 12 will be, we need to pick 6 random red using simple random sampling. And then the 17% of all 12 in the sample must come from purple. That will be approximately 2 purple. So we're going to use simple random sample to select 2 purple. And so rounding all of this together, or putting them all together, they will constitute the stratified random sample from the entire population. So in this case, you observe that in stratification, we first separate into distinct groups. Then out of those distinct groups, we select, using simple random sampling, the final elements or units that will be in the sample. Now, besides simple random sampling and stratified random sampling, which are foremost examples of statistical or random sampling techniques, we also have systematic random sampling, which is also another example of a statistical or random sampling technique. So how do we carry out a systematic random sampling plan. Let's say that in this case, the first step is you determine your population size. Let's say out of these 18 people, so 18, capital N tells how many units are in total in the population. We would like to select a sample of 6, size 6, to represent the whole group of 18. The first step is to determine your sampling interval or jump, which is represented by K, and is calculated as population size divided by the sample size. So that will be 18 over 6, which is equal to 3 in this case. So the next step will be this 3 will be used as the jump mechanism. That is, we're going to select one person out of the first 3 persons in the group. So we're going to choose randomly using simple random sample to choose one person out of the 3 persons. Let's say randomly we ended up picking the second person. So this second person has made it into the systematic sample, the final systematic sample. Then again, using that 3, we're going to count 1, 2, 3. That takes us to the 5th person. That person also makes it in. You count another 3. That takes you to the 8th person. We continue doing that. And so eventually, you're going to pick the 2nd, the 5th, the 8th, the 11th, the 14th, and the 17th person to constitute the final systematic random sample of size 6. This sampling plan is also called a 1 in every K, or 1 in 3 in this case. So this is very, very important. So our take home or our take out of our takeaway here would be that your final sample will have members in this position: 2, 5, 8, 11, 14, and 17. These people will constitute the systematic random sample. Now, the last type of statistical random sampling that we'll discuss is the cluster random sampling. This is mostly deployed when you're trying to pick samples from different geographical areas or sometimes from a cluster. So, unlike stratified sampling, units in this group may not be as what? May not be as heterogeneous as in the case of, in which case you need to separate them first. First of all, you divide your population into clusters, either by geographical region or by natural grouping. And then each cluster becomes a sampling unit. What that means is I'm going to name this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. I will write all of these numbers in a piece of paper, each of these numbers in a piece of paper, and I'll put it in a hat. I will shake it very well, and I'll randomly pick, let's say, about 4 numbers. Let's say I picked the number 5. So this number 5. So let me pick the number 5. And let's say I picked the number 2. I picked the number 7. And I picked the number 11. Every person in cluster 2, 5, 7, and 11 will make it into my final sample. This is what we call cluster sampling. So, cluster random sampling, systematic random sampling, stratified random sampling, and simple random sampling, again, are all examples of statistical or random sampling techniques. Why? It is because when you use these types of sampling plans, you tend to get a random and representative sample from the population. So let's test our understanding. Example, determine the type of sampling used. A soccer coach selects 6 players from a group of boys aged 8 to 10, and again, 7 players from a group of boys aged 11 to 12, and finally, 3 players from a group of boys aged 13 to 14 to form a rec soccer team. What sampling plan was used? What you might observe is that the entire group was first stratified, and so this would lead to stratified sampling plan as our final answer here. The next example, a pollster interviews all human resource personnel in 5 different high-tech companies. What this pollster must have done um, is that the person looked at each department and considered each department as a cluster of people, and so decides to randomly pick a particular cluster for different high-tech companies. So this would be an example of cluster sampling. Then 3, a medical researcher interviews every third patient from a list of cancer patients at a local hospital. This reminds me of jumps, 1 in every 3. Does that remind you of the example we did here? This is systematic random sampling. Then 4, a high school counselor uses computers to generate 50 random numbers and then picks whose names corresponds to the numbers. You're using a computer, that means you're letting a mindless machine get it done. No partial treatment or no preferential treatment. So this will lead to a case or instance of simple random sampling.